In this video, we're going to progress now to the point where you're going to have either properties provided or a graph provided, and you're going to have to use those clues to come up with a sinusoidal function that would describe either the properties or the graph. The first one I'll start with is the situation where you're given the properties. This one's usually the easiest to come up with. So in this example, you can see you were given that they want you to model a sine function. The period is 120. Well, what we need to make sure we realize is everything's going to relate back to our general form, y equals a. I'll use, this could be sine or cosine, doesn't matter. K. And we have your phase shift, it goes here. And then your vertical shift goes here. So if I just kind of highlight these as we go along here and remind you what they all mean. So this one out front, amplitude. And this value deals with the period. This value is your horizontal phase shift. And then this number at the end is tied in with our vertical shift, up or down. The A value can also deal with reflection. So if we take our properties over here and see if we can figure out all of these numbers that would go in here for these various letters. So let's take the first one. So the period is 120. So now remember, this number here does not give you the period, but we should know that the period is always equal to, so if you're going to do it in degrees, it's going to be 360 divided by k. Well, if I know the period is 120, they're basically giving me this number. That should allow me to determine what the k value is to put in here. Sometimes it's really obvious. You can just tell by looking at it. For example, the normal period of a trig function, sine or cosine, is 360. I can see this one is 120. Clearly, it's been cut by a third, which means the k value is 3. However, it's not always that obvious, so we need to know how to calculate it when necessary. So for example, in this one, if I knew the period was 120, put it in here, 360 over k, rearrange this and solve for k, so I'd multiply both sides by k. That would get rid of that. Now I'm down to 120k is equal to 360. So k would be 360 divided by 120. Which would turn out to be 3. So I know that number right there is going to be a 3. There's one down. The graph is reflected in the x-axis. That tells me to put a negative here. And again, that's just from our studies with functions that we are expected to know that. The wave has a range of -8 to 2. Now this is going to give us quite a bit of information. This is going to tell us, so we know the lowest point, and we know the highest point. So if you think about that, they're telling us that this wave is going to go between -8 and 2. Well, from that, I should be able to figure out two things. I should be able to figure out where the middle of the wave is, and I should be able to figure out how wide the wave is going to be in total. So if I go from -8 to 10, well, that's clearly 10 units. Sorry, -8 to 2, sorry. That's clearly 10 units. Well, the amplitude, if you remember what the amplitude is, if you're in the middle of the wave, how far is it to the high point or to the low point? Or basically half the width of the wave. Well, if I know the wave is 10 wide, well, then I know that A has got to be 5. All right, so I should be putting these down over here. So I know that A, oops, let me smooth that down. So I know that A is negative, and it's also a 5. So I've got that one covered. We figured out k already. We know that k is going to be 3. We know it's a sine function because we were told that in the question. All right, so we've got our a value, we've got our k value. Now, let's see what else I could get. There's a couple, I could figure out the middle of this wave, which would help me figure out the sinusoidal axis. And once you know the sinusoidal axis, you'll know the d value. But they basically tell you the d-value right here because it says the graph has a vertical translation of 3 units down. And hopefully you can recall that from properties that if a graph moves 3 units down, the original sinusoidal axis is always in the middle of the wave, which is normally at 0. Well, if you move the graph 3 down, d's got to be -3. So I now know that one as well. Whoops. That one is -3. Phase shift 60 right. Well, to make a graph go 60 right, you need to put C in as a -60. That's it. We got everything. So now we just go and fill it all in. So here's my equation. Y equals -5. Axis to make sine. Sine. K would be 3. Theta -60. And down 3. There's your down 3. So that's the equation. Now this, if this had been someone said, oh, what if it said cosine? It wouldn't make one bit of difference. The only difference would be I'd write cosine here instead of sine. So it doesn't matter. They're both done using the same strategy, which is a nice thing. All right, let's move on. So that's if they give you all the properties. This would be if all you have in front of you is the graph. So from a graph, you've got to be able to then identify all your different properties. And again, it's the same as before. We want to y equals a, sine or cosine, doesn't matter, k, theta plus c plus d. And we're trying to figure out what do I fill in for the amplitude, the k value, my horizontal shift, and my vertical shift. I got to figure those out from the graph. Well, there is a bit of a structure that I'd put to these if it was me doing them. I would always, first thing, is figure out where's the sinusoidal axis. So if I looked at this picture, now remember where it is. The sinusoidal axis is always in the middle of the wave. So if I look this over and see what I got here in front of me, so it's scaled off. You can see your scale here. You're going by 20s. And the 20s divided into 1, 2, 3, 4 blocks. So every little block's 5 on the grid. This is -2. So this must be +1. So the highest number on the scale is a 1 here. And if you go to the bottom, you are at -7. So if we have a wave running from -7 all the way up to +1, that's a total of 8 units. Well, what's half the width of a wave that's 8 units? It's got to be 4. So you say, well, from the top, if I go down 4, or from the bottom, if I come up 4, I should be in the middle of the wave. So let's see if we do that. So if we're at +1, and I was to go down 4 units, so there's 1, 2, 3, 4, and if I was to draw a horizontal line, like I'm going to do here now, crossed here, make sure I get that centered, and I would actually encourage you, now, not in your textbook, but if you had a piece of paper in front of you with a graph on it, I would encourage you to actually physically draw this line on your graph, just lightly, so you know where the middle of the wave is, because everything centers, or you read everything off, that's the middle point of your wave, your sinusoidal. Okay, so there's number 1. Well, as soon as you identify that, where that middle is, you've got your d value, because your d value always corresponds with your sinusoidal axis. So if this graph moves, look here, it moves, this is where your regular middle of your wave is. It's now down here at -1, -2 at -3. This graph has moved down 3, because again, that's usually the middle of the wave. Now the middle of the wave's down here. So I know D is a -3. All right. Well, then it says you should be able to figure out the amplitude, the period, and the vertical translation. Well, in my opinion, the amplitude and the vertical translation are extremely easy. No one should have any trouble with those. So let's look at this one. So, okay, well, what's the amplitude? The amplitude is half the width of the wave. We already figured out this wave is 8 wide, so the amplitude, the A value, has got to be 4. The vertical shift is always associated with your sinusoidal axis. We've already talked about it. It's down 3. So vertical shift, which is your D, it's got to be a -3. So I've got that number. I have that number. Now I need these two. And this one's going to be always the last one you do, the horizontal shift. Let's look at this one next. Okay, so this one, what you got to do is try and find defining points. Now, what do you say? What do you mean by defining points? Well, for example, let's say I picked this point, and I went all the way through to here. I think you'd agree and say, well, that would be one full pattern or one full cycle. So if I can say, well, the pattern started at 20, so pattern started here, it went all the way through the pattern, and it finished when it got to here. Well, if it started at 20 and it finished at 140, the definition of the period is what does it take on the horizontal scale to make one full pattern. So if I went across here, I'd say, well, that took 120. Now, remember, that's not the K value. Like the last question where they wrote out the properties, they gave you the period. It was actually the same as this one. Well, if the period is 120, then you need to use that to figure out K. So 120, which is the period, always equals 360 over K. Now, once you do enough of these, you'll realize in your head that you multiply both sides by K, then to get K by itself, you got to divide by this number. So K will end up equaling the period divided by, 360 divided by the actual period, which in this case turns out to be a 3 again. Now, that's going to allow me then to fill in this number, the K value. We know that one now. I just want to back up for a second and say, well, did I have to go? You didn't have to use those 2 points. So, for example, I could have started, let's say here. You got to pick a point that you can clearly see where it is, though, on this scale. So if I looked at this scale, that's -10 right there. And that's the start of a pattern because it's at the middle of the wave. Usually you either go from a high point back to a high point, see what that took, or you could go from a low point back to a low point, see what that took. You could go from here, the middle, back to the middle, see what that took. That would be a period. You could go from the middle and then go down first to there. That would be a full period. You can even do this. You can go half of a wave because sometimes they don't give you enough to see the whole thing. So that's half of a wave. Figure out what that took and then just double it. So those are different ways that you can figure out the period. So the only thing left to do is the phase shift. Now, this is the one that's got the most challenge to it. To do this one, it's really, really important that you know the basic shape of your 4 waves. I say, what do you mean by that? I'm going to show you down below here what I mean. The 4 basic graphs, I'm just going to scribble them quick, are sine, y equals sine, that's positive sine. So y equals sine of theta. The pattern it makes is it starts at the middle of the wave, goes up, down, back to there. Then there's y equals negative sine of theta. Well, negative sine of theta, all it is the same type of pattern except it's reflected. So it goes down first, up, and back to here. Then there's cosine of theta. Cosine of theta, from our studies, we know starts at the high point, goes down, back to the high point. Negative cosine of theta, its pattern starts at the low point, goes up, maximum, back to the minimum. These are the 4 basic patterns you need to know. Now, the thing with a trig function is, unless you're told specifically to make it a certain type of function, you always have the 4 choices. You can pick whichever one you want. And everybody could have their own choice. So there's nothing to say that my answer would necessarily be the same as the one that you choose. And you'll also see that you can pick sometimes more than one phase shift. So there are multiple answers that could be correct. However, having said that, everybody has to have the same amplitude, the same vertical shift, the same K value, the horizontal phase shift. Everybody, in theory, could have a different answer. Now, doesn't mean anything's right, but there's a whole bunch of different correct answers. Okay, so let's look at this one. And let's suppose I said, I'm going to do a positive cosine. So I go down here and say, okay, in my head, cosine, I remember the pattern. I need to find out a pattern where this graph starts at the high point and goes back to the high point. Notice that at a regular cosine starts at the high point at 0. And then it goes through, and it would normally be finished at the end of the pattern, which is normally 360. Well, if I go up to this graph and have a look for a positive cosine pattern, I could say, well, here it is right there. Look at that. It's at a high point. It starts, goes down, back to a high point. That's how a positive cosine pattern is defined. Well, the problem is, here's 0. A regular positive cosine is supposed to start that pattern right here. It's not. It's actually moved over. Which way? You say, well, it went right. From its original starting spot, it went right. How far? It went right 20 degrees. So that could be a phase shift that I could use to describe this graph. So I'm going to go y equals. So we said the amplitude was, I forget my numbers now. Amplitude is 4. So y equals 4. We said we went positive cosine. I said, what do you mean by positive cosine? This number in front is positive. Y4 cos, our K value is 3. We said that we would need a phase shift of moving theta to the right 20. And then we would have to move, our vertical shift was down 3. There you go. That would be one correct answer. I say, okay, what do you mean one correct answer? So I may say to you, well, I want you to write it as a negative cosine instead. So what do you mean by that? Well, look at your picture down here, negative cosine. I want the pattern to start at a negative, a low point, go up to the high point and down to here. Well, you got two, there's one, here's another one. So you may say, well, what if I start here? Sure, that will go up, down. Now it's supposed to start there at 0. Well, it's not at 0. You say, okay, well, it got moved left 40 degrees. So I could write out y equals, just switch this to a negative. That indicates now it's a negative cosine pattern, which is this pattern. And in order to get that pattern started properly, the graph had to move left 40. So I would put here plus 40. Now notice, the A did not change, the K did not change, and the vertical shift did not change. As you go from sine to cosine, positive sign to negative sign, none of those three change. The only thing that changes is the phase shift and whether you determine you want to put a negative in front to give it a reflection. Okay, so let's continue. Let's do 2 more. Let's do all 4 of them. Let's do a positive sine pattern. So positive sine starts in the middle, goes up to the high point, down to the low point, back to the middle. So I'm going to look this over and see if I can figure out where that pattern would start. Oh, let me back up for 1 second. So somebody else may say, oh, I didn't have plus 40 there. I went right, which would also be okay because that starts the same pattern. So if you went here, right, that's a negative cos. So somebody else might have had their phase shift right 80. So instead of plus 40 here, they might have had minus 80. They would also be correct. One thing to notice, if I was correcting these, I can quickly tell those are both right because plus 40 is left 40, minus 80 is right 80. Well, minus 40 to plus 80 is a difference of 120, which is the period of this graph. And we know that means that the graphs start repeating themselves again. So this graph repeats its pattern every 120 degrees. So I can quickly tell because those 2 angles are 120 degrees apart, they're both right. And that's a quick way that you could tell if your answer is the same as a classmate's. If the 2 angles are whatever the period is apart, they're both right. Okay, let's go back here to sine again. So positive sine for sine, bracket. Remember, this doesn't change. Theta. The only thing that's going to be different is in here. We'll figure it out in a second. All right, so notice all of those stayed the same. Positive sign. So I was saying it starts in the middle, goes up, down, back to the middle. Well, do you agree if I went right on that dot? That would be, these are always, and again, I always think like I'm reading a book going left to right. So if I started here and went this way, I would go up first, down, back to the middle. That models this, up, back to the middle. That's supposed to be starting the pattern at 0 if it's a regular sign with no phase shift. Well, it's not at 0 because 0 is right here. So it's actually moved left, right, left, 10 degrees. So left 10 is a plus 10. Now somebody else may say, well, I went way over to here to get the pattern. No problem. That's right too, because that's going up, down, back to the middle. They say, well, I went right 110 degrees. So right 110. And like the last one, I can quickly tell, yep, they're both right, because that's negative 10, that's positive 110 in terms of where they would be on the scale, which is a difference of 120. Makes sense. Last one. What if it was a negative sign? So negative 4 sine 3 theta. Again, notice nothing's changing except the phase shift. So now it's a negative sine wave. Well, move down a bit here. So a negative sine wave, the pattern, and again, you need to know these 4 patterns. Negative sign goes down first, up, back to the middle. So one thing I should have mentioned, sorry, way back when I started here, is we're always looking at the middle of the wave because these patterns are built around the middle of the wave. So I'm always looking at my sign. That's why this line, I said it's useful to put it on your graph. So I'm looking for a pattern that starts in the middle, goes down first, up, and back to the middle. Well, there it is. That's really the only one I can see unless I'm way over here. Usually students will pick the closest one they see. They don't have to, but that's usually what will happen. So let's say there. If I was there, I'd go down first, up, back to the middle. Well, that pattern, if it's just negative sign with no phase shift, is at 0. Well, it's not starting at 0. It's actually moved to the right 50 degrees. Right 50. So I'll go down here. To make a graph go right 50, we just put a minus 50. And there you see 1, 2, 3, 4, 5, 6 different equations that someone could have written that would all, if you were to go to Desmos, type in any of those 6, they'd look exactly the same as that wave that we just drew there. That's what I was saying earlier, that there's always multiple different answers you could come up with. Now, sometimes the question may say, determine a positive cosine wave. Well, then you got to pick one of these ones. You may say determine a negative sine wave that describes the following graph. Well, then you got to use this one down here. But if it's left wide open, it's always up to you to choose. And sometimes it's easier to use one than the other, as you'll see when we do some examples here coming up. But that's kind of the gist of how I read all that information off of a graph. All right, so we're going to do a couple more. Okay, so after going through that first example and reading a function from a graph, we're going to do a few more. I'll probably go a little bit quicker now. Remember, it's not like class, so if you don't understand, you can pause the video, you can rewind the video, whatever it is you need to do. So I'm just going to kind of go through these now as if I was doing them on my own. I'll still explain what I'm doing, but it'll probably be a little bit quicker than the first one. All right, so if I read the instructions, it says I want both a sine and a cosine, so I got to do both. Now that doesn't mean when it says sine, it could be positive or negative. When it says cosine, it could be positive or negative. It's your choice. Okay, so if I was starting this from scratch, I would look here and say, okay, I always like to start with the amplitude first. It's usually one of the easiest ones. I'm going to start with the amplitude. This wave goes up to 8 and down to minus 6. So that's a total of 14, which means the wave should be, the middle of it should be 7 from either the top or the bottom. So if I'm at the bottom and I go up 7, I'd be at 1. Now let's just check. So if I'm at 1, up to 8, that's 7. And if I'm at 1, down to negative 6, that's 7. There's the middle of the wave. So I know the amplitude is 7. Put my sinusoidal axis in. I'll use my grid here. Here's my sinusoidal axis. Okay, let's look at the Yeah, let's do the vertical shift next. That's always fair. Once you get your sinusoidal axis, this one should be easy too. So vertical shift is up 1. Next is the period. The period, let's see. Again, use your sinusoidal axis. Don't look for intercepts down here. So look, let's say I start here. Yeah, that's not a great one to start. I could do it. Let's figure their scale here. So I'm at 80, so 20. So every block is 20. I could use that one. So if I start there, I'm at negative 60. You got to go through a whole pattern. Down, back, to there. Remember, every block's 20. So this would be 640, 660. So it starts the pattern. Sorry, it ends the pattern here at 660. 60. And it started, we said, at negative 60. So negative 60 all the way over to 660 would be a total of 720. Okay, so what K value is that going to give me? If you can't tell by looking at it, I can tell by looking at it because it's double what it normally is, which means the K value must have been a half. Anyway, I'll show you how to calculate it. The period always equals 360 divided by K. Multiply both sides by K. 720K equals 360. K has got to be 360 over 720, which is equal to the fraction 1/2. So we've got our K value. Well, we're pretty much ready to go. Again, it's just up to our phase shifts now. So let's start with let's go with our sine wave first. So I'm going to go Y equals, what's my 7, I think it was. So amplitude is 7. Sine, K value is 1/2. Theta, just leave some room here. We'll come back to that one. And our vertical shift was up 1. All right, let's go look this graph over. Well, let's go right here. If I went right there, that would be the start of a positive sine pattern. We'll look a bit. Agree. So if I was here, up, down, back to the middle, that's the pattern of the positive sine wave. Well, it's supposed to start at 0. It's not. It's moved left 60 degrees. Left 60. There I have it, a sine wave. So I went with positive sine. Somebody else may have said, oh, I did negative sine. Well, they would have went here instead because that's down first, then up. And their phase shift would have been right 300. Okay, now I'm going to do a cosine. So Y equals 7 cosine 1/2 theta. Leave some room. We'll come back to that one. Plus 1. Remember, none of that stuff changes. So your amplitude, your K value, and your vertical shift do not change whether you're going sine, cosine, negative cosine. Okay, positive. So if I go positive cosine, if you remember, starts at the high point, down, back to the high point. Well, that would be the start of a positive cosine pattern right there. Supposed to start at 0. It's not. It's moved right 120 degrees. So right 120 would be minus 120. That would work. Somebody may have said, I went to here. You can go to there, but then you'd have to put a negative out in front. I'm just going to put it in red here just to show you. So if somebody said, I went here instead, you're talking about a negative pattern because it starts at the bottom, goes up, back to the middle. Well, then your phase shift would have been to the right 480 degrees. So if you went negative, your phase shift would be right 480 instead. There you have it. So there's a sine wave and a cosine function for that one. Let's move on. Okay, another graph in front of us. So the first thing you may notice different is your scale now is in radians. I'm going to leave it in radians. I've seen students in the past just switch all these to degrees because they're much more comfortable in degrees. I recommend you try and get comfortable with radians. Again, if you don't work with it, you'll never get more comfortable with it. If you're going to take more math, pre-calcs and calculus courses, you have to become familiar and comfortable in radians. It's the unit of measurement for angles as you move beyond into higher level math courses. Okay, here we go. So this one, same deal, wants both sine and cosine. So we will do both. Start with the amplitude. So the top of the wave is at 0 on this scale. The bottom of the wave is at -6, so that's a total of 6, which means the amplitude is 3. Remember, the amplitude is half the width of the wave. Let's do vertical shift. So to do the vertical shift, you always want to get your sinusoidal axis. So let's put a horizontal line across the middle of this wave. Well, the middle of the wave should be at -3. So I'm at -3. There you go. Now, the vertical shift then is down 3. So down 3. Period. So let's map out one full pattern of this. Now, this is where because of the fractions and on the scale, that can throw some students off. Well, I'm going to go to here because it lines up perfectly with this point. You could use this point too, but then you're going to have to figure out what the scale is here. If I look at this is pi over 12. Pi over 12 has been divided into 1, 2, 3, 4 equal blocks. So if you take pi over 12 and you divide it by 4, that's the same as multiplying it by 1 over 4. Every block on this scale is pi over 48. So this would be 2 pi over 48, so that means you're at pi over 24. And again, you can work with that if you want to, but I'm going to go to this one that's clearly lined up under that number. And I'm going to follow that pattern through and see where it ends. So I started at negative pi over 6. I went through the wave, done, at pi over 3. Okay, now back to our story last week about wrenches. If you're saying, well, I don't know, how can I tell how far that is? Get a common denominator so you can map it out. This, instead of writing it as pi over 3, just write it as 2 pi over 6. So if you're at negative pi over 6, and you finish the pattern at positive 2 pi over 6, well then that must have taken you 3 pi over 6s. So the period on my scale, what did it take to make one full wave? It took negative pi over 6 over to 2 pi over 6. Another way to do this is if you take the right number and subtract this number, it'll always give you how far apart they are. So if you had a calculator that would do fractions for you, I could have just went, never mind the pi's, just say I'm at 1/3, and I take away here, which is negative 1/6. You have to include the sign there. It's going to give you the same answer I'm going to get here, which is basically what I'm doing. I'm going to get common denominators. I'm going to go 2 pi over 6 minus a negative pi over 6, which is going to give me 3 pi over 6. That reduces pi over 2. So this graph has a period of pi over 2. Now, when you go to figure out your k value, again, don't switch back to degrees, just work in radians. So the formula normally is the period is equal to 360 over k in degrees. Well, in radians, it's 2 pi over k. So the period, which is pi over 2, has to equal 2 pi over k. Let's cross multiply, so k times pi, and 2 times that is 4 pi. Well, divide both sides by pi, and you've got your k value. Divide by pi, divide by pi, k turns out to be 4. And if you think about, this is 90. The normal period is 2 pi, which is 360. Well, 90 is a quarter of 360, so pi over 2 is a quarter of 2 pi. That makes sense, then your k value should be 4. All right, here we go. Y equals, I'll go sine first. So my amplitude was 3. Sine, k value was 4. Come back to phase shift in a second. Vertical shift was down 1. Now, just to show you both, this time I'm going to say, I'm going to go negative sine. Well, remember, negative sine goes down first, then up. So this would be no good because that goes up and then down as I go left to right. This one, though, goes down first, then up. So if I go here and say, well, my phase shift is right, look at my scale again. right pi over 12. So to make a graph go right pi over 12, I would put here minus pi over 12. However, I got to make sure I put a negative here because if I go right pi over 12, I'm modeling a negative pattern. You could go left pi over 6, so put plus pi over 6, and then make that a positive instead. Then you'd have a positive sign pattern. Here's cosine. Y equals 3 cosine. K value is 4. Phase shift minus 1. Cosine. I could go there for a positive cosine. I can go here for a negative cosine. Let's do this one to make us think a little bit more. This one's a little tougher. Okay, so you say, well, I've moved to the right so many units. So, well, I don't know where it is. Well, there's a few ways you can figure it out. It's halfway between these two. Well, every one of these blocks, we looked earlier, remember I said it's pi over 12 divided into 4 equal blocks. Pi over 12 divided by 4 is pi over 48. Just count the blocks. Say, well, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 10 blocks to the right, every block being pi over 48. Now, 10 pi over 48, if you reduce that, is 5 pi over 24. So in radians, my phase shift is right 5 pi over 24 if it's starting at the bottom going to the top, which that's a negative cos pattern. So there would be 2, so I just picked negatives this time to make it a bit more of a challenge, but truth be told, you could have picked this one right here and went left. So left, 2 of these blocks, every block's pi over 24, or say, well, what's half of pi over 12? Pi over 24. So you could have went positive cos and put your phase shift here as pi over 24. That would have been correct as well. All right, I think we got one more. Okay, so if you walked into this one, let's back up. Yep. If you looked at this one, this is a graph that if we look at it and say, well, these are not angles. They don't have to be angles. They just have to be numbers. Doesn't matter what they are. If they're just numbers, you're going to get to choose whether you're going to work through and model this as a sine or a cosine function in radians or degrees. Most people are more comfortable in degrees at this point. Give it a few years, you might be more comfortable in radians. But I'd say most of us will probably right now still go to degrees. So I'm going to look at this, and I say it just wants one, any trig function. Well, what I do notice about this graph is that these high points are lined up right perfectly above the numbers that are on the scale. So I would suggest you probably are going to want to make this one be a cosine graph just because they line up nicely. But again, it's really up to you. All right, let's start with our breakdown. Amplitude. Well, negative 24 is the bottom. Positive 24 is the top. So that's a total of 48 units. So the amplitude is 24. Well, you notice this one, the middle of the wave is still at 0. It's up 24, down 24. So the vertical shift, there is none. Period. Let's see what it takes to make one full pattern. Well, nice. Let's start here. We'll go up, down, done. There's the period. So the period is 0.8. Let's use that to determine the K value. I'm going to do it in degrees. So the period always equals 360 divided by K. If you're in degrees, you can put 2 pi there if you wanted to work in radians. The only thing you'd have to do differently is when you do a calculation using this, you'd have to make sure your calculator is in radians. Okay, cross multiply, so I get K would equal 360 divided by 0.8, which I'll grab my calculator and do that out. 360 divided by 0.8 is 450. There's your K value, 450. Oh, here I go. Y equals I'm going to look this over and decide whether I'm going to go sine or cosine, positive sine, negative cosine. Well, I think the best choice, if you look at 0, this graph is right at a low point, which is the perfect spot to be if the graph is making the pattern negative cosine. So I'm going to go negative amplitude 24 cosine. My K value is 450. What did I have for phase shift? Oh yeah, we said there'd be none, so it's just theta. Some people put the plus 0, they don't need it. So there is no phase shift, and there was no vertical translation. There you go. That function would describe this graph. Okay, so hopefully that gives you a little bit of direction on how to come up with a trig function or a sinusoidal function to describe a wave pattern. In your textbook, there's 3 really good questions on page 252, numbers 14, 15, and 16. Remember, the PDF file is under the file section on the general channel of our team page. So if you don't have an actual textbook in front of you, you can easily get the questions there. We'll advance to applications of this, how we use this in word problems next week. And yeah, so hopefully by the start of next week, you've got some comfort level with determining the equation of a sinusoidal relation, looking at the graph, or if I gave you all the properties. Best of luck.